Did you start the broadcast?
Yeah, so
Okay.
do you need that computer?
I'm just getting the data before.
Okay. Right, so shall we begin with the first question?
Yep. Yeah.
Yeah.
Hey.
Mhm. Okay, so I would start by writing the equation of the reaction.
Okay. Well, can I find out how many moles of CO2 are produced?
Yeah, that's by so the reason I think it's best if you write the equation first, so it makes you clear like what are the products and what are the reactants. So what is the ratio that you're looking for?
Okay. Well, we don't really know what this is.
Yeah.
We also don't know what this is.
To reduce the single hydrogen gas.
Hydrocarbon gas.
Yeah.
Yeah.
Yeah, so you can write it as Y maybe.
Yeah.
And then Y reacts oxygen. Yeah. So it's basically just two steps, so it's more clear, so you're working on this and it's like drawing a diagram for mechanics.
Okay. So room temperature, volume. Okay. So I'm gonna calculate the number of moles. So this is what I got.
So because it's a hydrocarbon gas, means that it only has hydrogen carbon. So so there's no oxygen, so you can actually balance the equation by using you can try to balance the equation by using the fact that the oxygen at the right hand side and the left hand side are the same.
Okay.
So you would have
Well, I know the amount of moles of CO2 produced, right?
Yeah.
So now I also know the amount of moles of Y.
Yeah.
Which is 1 mole. And then I know the amount of moles of Y here. So that's equal to X. So the amount of moles of X is equal to the amount of moles of carbon dioxide.
Yeah, but okay. Yeah.
And then I also know the mass.
Yeah.
48. Now I know MR is equal to 48. I think, right? Was that wrong?
So
No, that's not right.
to have yeah, so we just use that divided by this. Yeah, so as a matter of fact, so what you're equating here is you can ignore the aluminum.
Okay.
So for now, you can ignore the aluminum because you are producing from this to the carbon dioxide, right? So the number of moles of carbon is conserved. So basically, the number of moles of the carbon dioxide which you worked out is equivalent to number of moles of the carbon if they were in single atoms. You see what I mean?
Yeah.
So basically, you can work out how many carbon atoms are there, right?
Yeah.
And yeah, so how many? So you have. Okay, so basically you have 4.5 times 10 to the power minus 3 moles of carbon dioxide. That's what you worked out, which is equivalent to number of moles of that. So and then you times it by what is the molar mass of carbon, which is 12, and plus. So if you let this be x, maybe we have x there already. Okay, maybe let the number of aluminum be z. Okay, so z plus yeah, z times so so you have, for example, you have 3 here, right? So you work out the number of so the moles of the whole compound by dividing this by 3, right? So like this is the number of carbon atoms divided by 3 equals to the amount of that, and then you can work out the mass and to see if the mass agrees.
Yeah.
You see what I mean?
So like, I can find out. So by finding out this,
Yeah.
right, I can find out the mass of C in
Yeah, you can
X,
find
right?
mass.
Yeah. So if I know the mass of C in X, then I also know the mass of Al.
Yeah.
And then I just okay.
And then you divide by
both of the atomic.
Yes.
And then I can get the formula.
Yeah.
Okay. Should we do that?
Yeah, so that's what I was writing here. So yeah, so this is the mass of the this is the mass of the carbon, and plus so we set that as a number of the aluminum times the mass of aluminum, which is aluminum, which is 27. That is equal to the total mass.
Yeah.
And then you can just work out the equation of that.
Yeah.
And then the ratio would be that over that. Yeah. Yeah.
Okay. We got it on?
Yeah.
Yeah. So
will be
B. Yeah, decrease of mole
Yeah.
number. B.
So
No. Wait. Oh, sorry. No, intermolecular process. D.
Yeah, so what are the definitions
D.
for ideal behavior?
Ideal behavior is where the the pressure is anti-proportionate to its volume,
Yeah.
and the volume is proportionate to the pressure is proportionate to temperature and number.
Yeah, so direction.
Yeah.
And I mean, the definition of ideal gas would be that there's no intermolecular forces between.
Yeah, so
they exist
volume
as
is
single.
negligible.
Yeah, so if you compare the ammonium to Nara, obviously ammonia would have a higher
intermolecular forces.
So why? So okay. So if we compare sandies, why would the high temperature result in more ideal behavior?
Because when you have a low temperature, the intermolecular forces prevent pull the molecules in the opposite direction of the wall. So the pressure created will be less than the real gas.
Okay. Yes. Yeah. So if
Because
we. Yeah. So the pressure.
They're moving more slowly.
Yeah. So the pressure will be less, and then. Yeah. So which means yeah. So basically at lower temperature it will be more viscous.
Mm-hmm.
So yeah. So they are closer to each other. Number 6. That's just a calculation. Just maybe set out the equations.
Should I
Yeah, just write what is the equation for the.
Okay, so I'm just gonna draw an enthalpy cycle.
Yeah. Yeah, but basically, you don't have to like work this out in the positive module twice. So
I would just
yeah. So and then you add this side, you minus this side by that side, and you get the entropy of change. Number 7.
No, sorry.
You don't have to. So basically, if you think about this reaction, what type of reaction? I mean,
It's a redox reaction. Oh, and they're asking. Okay, so that's -2 -6 +3. So it goes from 0 to +3.
So it's
gain oxygen L. So it's been oxidized.
Yeah. So they lose
and it's lost.
Yeah.
3. So lost 3, oxidized N.
Remember it. This is just a like with the titration.
Yeah, what are the oxygen?
Yeah.
Okay. So, copy.
Yeah. Yeah. The temperature changing to 6 temperature. So is it decrease or increasing?
There's an increase in temperature.
Yeah. So the original temperature was 500. So there is an increase in temperature. So what happens?
So the yield decreased of ammonia.
So what? Yeah. So what? So how the increase in temperature favors the equilibrium? Is it to the left or to the right?
To the left.
Because
it's exothermic, so it favors the endothermic reaction.
So make the yield decrease.
Yeah. But it increases the kinetic energy.
Yeah.
So it's formed faster.
Yeah. So
but yield is decreased. So.
Yeah.
Okay.
Yeah, then you just swap it to solve the equation.
Yeah.
11. Yeah, when we have these kind of questions, there's no, you just have to read it one by one.
Yeah. Okay. So the temperature.
Why? So what would happen to
So this is what it would look like.
Yeah, so what would happen to height?
It would decrease.
Yeah, so to balance the area.
Yeah. Maximum goes to the right.
So, and then don't need.
No. C.
Okay. Yeah, so the first one is neutral.
And the other one is neutral. Okay, wait. Orange.
So do you know the melting point? You don't know the melting points in the data book. There's no. There's no such. There's no melting point in your data book.
No.
Yeah.
But I do
Or-
know, I know the relative. So like
Okay.
it increases from magnesium to silicon, then decreases. So magnesium is this is the lowest, this is the highest, and then this increases from here to here. So ionization energy.
I would first look at the periodic table.
Well, I know that. So I know what happens. So ionization energy increases,
Yeah.
then decreases, and then increases again.
Okay.
So increases. But like okay.
So basically ranking.
Yeah. Okay. Maybe I should.
But this graph is so you right, so if you I'm not sure about this, but if you know that it's actually like in this pattern.
Yeah.
But you cannot compare it with it because
I know because it's also
because it's not the same axis.
yeah.
So the point about that is basically to find the relation between the first ionization energy and the melting point. I would think.
Yeah.
So this is a graph of melting point against first ionization energy rather than to rank the melting point or to rank the first ionization energy.
Yeah. Okay. Sorry. Yeah. I get this. Oh no. Okay. Higher. Okay, it's not this because Mg is first ionization energy is higher than aluminium. So
Yeah.
it's either this
Why is
or
Mg
this.
higher than aluminum?
Because the electron removal is in the p orbital, not the s orbital. And
Yeah,
this is
because so
partially
it's more-
screened
yeah.
and higher distance.
Yeah.
So it's either this or this. And then it's this. Yeah, it's this.
Okay, so what about silicon?
Silicon is a giant covalent compound. So
So it has
the
the highest
highest.
melting point. Yeah. And then phosphorus would have the highest first ionization energy because
as you go.
yeah, it's further to the right of the period. Yeah.
Ox.
The oxidized substance will be the one which loses.
Yeah.
Which loses proton and increase oxidation number.
This reaction, as you go down the group, it gets more close. It's D.
Yeah. So if you check the periodic table.
Yeah.
Because the fact they are both oxidized means they both lose electrons, and as you go down the group, the electrons, the ionization energy decreases.
Yeah.
Because the more expanded orbital. So, yeah.
Okay.
Yeah.
Okay, so 0 minus 1 for NaCl plus, okay, NaClO, NaClO3 plus 5 plus 1 plus 1 plus 5. A.
Mm-hmm. So do you know the reaction of hitting the hydrogen halide?
Yeah.
Have you learned about the reaction?
Yeah.
So what happens during the reaction?
Yeah.
Your hydrogen gas and the halide.
So it's
Yeah.
D.
So why would there be no change for the bromide?
Because it has, it's more it's more stable. So you'd require higher temperature
What do you mean by more
to boil.
stable?
Well,
Yes,
I mean,
yes.
you need a higher temperature to decompose.
Yeah, but why? So why? So the fact that it doesn't react is because it's more stable. But why would it be more stable?
Because it has a higher bond energy, and that's because it has a smaller bond.
Yeah,
Bond
so
lines.
it's the size of the.
And what overlap.
Yeah, that's the size of. Yeah, basically the size of the halide line.
Yeah.
And the electronegativity.
Yeah.
Which creates a stronger bonding.
Yeah.
18. I don't know what time. Sure, I think, but I don't think we can go through.
Yeah.
Probably just first.
Okay. Ammonia is a weak base, right?
Yeah.
That means that ammonia molecules and ammonia ions. Yep.
So yeah.
Oh.
Have you got the right balance?
No.
I mean, you just add half to the nitrogen.
Yeah. But I could.
Yeah, and then you can double them.
Okay. So 60. Well, yeah, 14 plus 16. 2 mol.
No,
2 mol.
and 1 more.
Yeah, and then times the molecular mass.
Yeah, which is
Uh,
14 times 2, right?
Yeah,
So
28.
that would be just,
or
yeah,
something like that.
that would be, you should see.
Yeah.
Number 20, which is a single substance.
Single substance.
So which means that the one with has no isomer. I mean, obviously D is not going to be.
No. Single substance means they have no
Yeah,
isomers.
so basically if you look at A, B, C, and D, right, so D is obviously not going to be the one because it obviously have structural isomers. And if you look at ABCs, all of them, none of them will have structural isomer. The reason is because it's listed as a structural formula, structural chemical formula. So the only difference between B and C is that one will not have the stereoisomer, but the other two will. So what type of stereoisomers have you covered? So you have optical isomer and also
geometric.
Yeah, so double bond, right? So if you look for double bonds first, because it's easier to find, right? So B has a double bond, right? You can immediately see. So B would have stereoisomers. I mean, it depends. So if not all the double bonds will create stereoisomers, but if they are bonded to kind of two different groups, so that would be like the methyl this way or that way.
I get that, but I've never heard of single substance.
Oh, so that just means. So if you look at the first part of the question, we consider one.
Oh, so which one only has one of them?
Yeah, so which one does not have a structural isomer or a stereoisomer?
Okay. Yeah, it's B. Yeah. So you said.
No, I said B is not.
It's not B.
Yeah, because B has a double bond, so it would have a. It's likely to have a stereoisomer. In this case, it in fact does, because you have the methyl group this way or that way. And what about this?
It is.
C also has a double bond, right?
C does it have a double bond?
So the carbon there is bonded to.
No, C.
So C would that's right. So C is not, but and now you're comparing.
It doesn't have a chiral center either.
Yeah, so you compare A and C, right? So it also doesn't have a double bond.
It doesn't have a
it doesn't have a carbon double bond. But it has a chiral center.
A has a chiral center.
So A and C, so which one has? So A has a chiral center, right? Because there is one carbon that is bonded to 4 different groups. If you draw structure, so A would not give you a single substance. So C would give only one, which gives you a single substance.
Yeah, that makes sense.
What do you want?
Oh no.
So you're just adding all the items. Just adding all the items. So if two identical, so just finding the
5-membered ring. So that means it has 5 as a base. Yeah. Right?
Sorry?
A 5-membered ring.
Yeah.
Means that it has 5 as the carbon base.
Yeah, but it's a ring.
Yeah.
So it would be a ring.
Like, yeah. And it's tertiary alcohol group. Okay, so it has to be bonded to 3 and OH. Okay.
And it's still missing 2 carbon. That's it. No, sorry, one carbon, yeah.
But that's the carbon that makes all of these isomers. Okay. So can be bonded to this. That will give one isomer. This will give another. And then these two would be the exact same.
Yeah, because it's symmetric.
So far 2.
And for each of them.
Sorry?
Yes, and for each of them, you would have how many carbon centers?
You have 1 here. You have 1 here.
Yeah, so
chiral center.
Yes, so we have two different structural isomers, right? This one, that one, right? And if you consider each of them, So if you consider this separately, so you have one chiral center here
Mhm.
and two chiral center here.
Yeah.
Then another one.
Well, we had one cut.
Yeah, but so we consider one of them.
Just this.
Yeah, just that. Yeah.
Then no, we don't have any.
So that will give you four.
Four.
False. That will give you false chiral isomers for that.
Yeah. And
structure.
then for that guy, you already have 1, 2, so 4, another 4.
Yeah.
And then you're already over 9, so it has to be 13.
Okay, so
No?
yeah, so basically we had 4, right, for one structure.
Mhm.
And now we have 4 for another one, so you have 18.
No.
Why is it over 9?
No, sorry, I was counting these, but we already counted them.
Yeah.
Okay, that's good.
So 8 is not a choice, so we need to find. I mean, it's unlikely we'll get to 13, right? Because
no, I don't know.
So most likely answer will be C.
Yeah.
So we just need to find which is the other isomer. So what do you think?
It could be that the carbon is bound.
Yeah, so it's as obvious. So you have another structure, but this one, well, okay. So but that one it has actually no, it does not have chiral center because this and that is the same. So you just have one there.
So 9.
Do you want to continue or?
I don't mind.
Okay, we'll probably do like up to 30.
Okay. D.
Yeah. When you look at those names, would you have like already have a structure in mind? I mean, when you do the model, I mean, like if you look at
ethyl propanoate, that's an ester. Or is that what you
yeah, but here we are like figuring out the reactions between the pairs. I mean, so I would it depends. It's up to you. I would draw the structure of the propanoic acid, and then just sort of have a picture in mind.
Okay.
So what would be the
propanoic acid, the structure of that?
Yeah. So, I mean, when you draw the structure, you don't.
Yeah, okay.
You don't have to. Yeah. So that would be just something.
Propionate. Heating. No.
Yeah. So that would be.
That's definitely not.
Yeah.
That's all. Heating with acidified potassium.
This is a 2O, so yeah, so it'll give you ketone.
Heating propyl ethanoic. No, you get ethanoic acid.
Yeah.
So it's this one.
Yeah. I mean, it's the fact that. Sorry. Yeah. So it's a neutralization reaction, which because it's acid and yeah.
So this can't be that because the double bond's not there.
Could it be C? If you polymerize a alkene, what do you get?
You get like an alkane.
So you get alkane, right?
Yeah.
So alkane can't be hydrolyzed. I mean, how would alkane be hydrolyzed?
Yeah, but the alkane would be a halogenoalkane.
Oh, okay, I didn't say that.
So,
right, yeah, I see what you mean. Yeah, but then, yeah, I see what you mean. Yeah.
This can't.
Yeah, so if you
This
have,
could.
yeah, but if you have a 1, 2,
1, 2. Oh, they're talking about 1, 2. Okay,
yeah,
then
but
it's not. And then this one would have 2 H's.
Yeah.
Okay, so it's not that guy. It's this. It's A.
hold on.
Yep.
Cool.
Wait.
How do you?
No, you can't hydrate a
Yeah.
alkene.
So you,
Okay, wait. So something. Polymerase ethene followed by oxidation. That can't be there. That can't be, because you need a double bond for that to happen with coal to acidified potassium manganate.
Yeah.
And when you polymerize it, you get rid of the double.
What about D?
Oxidation. Yeah, it's D.
Why would
Because it can't be the others.
Okay, so but D also, so if as I said, you need double bond. Right? But if you
Yeah, but
polymerize
it's a
ethane,
halogenoalkane now, so maybe you could read it. I think
it should be
it's D
C.
because
Numbers, it should be C.
it's C.
Because if you draw the 1, 2,
yeah.
you
So
just trace it the other way.
Yeah. Oh no, because 1, 2.
So that's
means
so this is a
CL,
polymer.
CL.
Yeah.
Yeah, so it did make sense. Okay, I get it. I was a bit.
So C would be the right answer because 1, 2 means.
Yeah.
25.
Otherwise it would be 1, 1.
Yeah.
Prony acts with ethene in the dark. What description?
What is the intermediate?
Huh?
What is it? What is the intermediate reaction?
It's a carbo cation.
Yeah, so that's so it likes.
So it's positive. It's an electrifier.
It can't be A and B obviously.
No,
Yeah,
it's not
so
free radical.
That would be D. 6.
Statement about into one object into is not correct. That's correct. That's correct. I do not know.
They can all be dehydrated to a alkene.
Will be oxidized. 2-methyl. Yeah, not you. This one's not correct, so it's D. This is a tertiary alcohol.
Yeah. So it can't be.
Compound, yeah. So that's background with. Okay.
I'm just looking for like. I say if I means
I
that
know.
goes to carboxylic acid.
Yeah. Certified. Nope. Your ketone.
Yeah, B can't, right? Because it's not in the primary calculation, so it can never be acidified.
No, but it can react with acidified potassium.
All right, so it's not acid. Okay.
Yeah.
But the alkene aqueous iodine means.
Yeah, that's the CHI3 thing.
Yeah, so that would give you.
So you need to have. So it's not this.
Well, what?
Because this is what it tests. So you have to have this.
Yeah.
And then whatever.
Yeah.
This one does. Yeah. Yeah. This is.
Okay.
Yeah. This one, great. This reduce excess. Hey, well, sodium. Yeah. So it will break that bond, break that bond, break that bond, and that one.
Okay.
So speed.
Yeah.
Yeah. Generic acid can be produced. Okay, so 1 bromo probe. Oops. Okay, so there's an extra C. So just one for you. Acidic. Yeah, this one. A.
Yeah. Why is it acidic?
Because it reacts with the acid because it's basic to form
It gives you
this
carboxylic acid.
plus carboxylic acid.
Well, yeah, so do you know the mechanism?
I do not know the
Well, it's not really. I mean, yeah. So it's basically the same as if you would have a. I mean, you know the typical mechanism for the carbon.
Oh yeah, I know that. Yeah.
But so for this one, it's basically you have a. I mean, it's a similar pi system to carbon.
Is this like A2, like amino, or?
So you have a nitrile group,
Yeah.
and then you have acid which activates it.
Okay.
It's the same thing as if you would have the reaction for the carbon.
Nucleophilic addition.
Yeah, so the acid is there to activate. It's not really a traditional acid-base reaction. So the acid is acting as a catalyst.
Okay.
Instead of actually taking part in the reaction. So it would activate the nitrogen and nitrile. This in turn makes the carbon more electrophilic. And then now the water can attack this carbon several times until the nitrogen is kicked out. And then you're going to be left with carbon. So number 30. Yeah. Number 30.
Primary alcohol. Okay. So. Okay.
Yeah, just have to. I mean, yeah, there's no way around it. But yeah. Yeah, just have to like move it around the string, and then it's very likely to make mistakes for this kind of.
Yeah, I know. Like C. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2.
Okay, so I mean there is a bit of mistake made here, right? So if you think about the symmetry of this compound,
well, yeah, there's a carboxylic
so
group.
yeah, so
I mean the double bond with the.
oh yeah,
Is that
so
what you mean? Yeah.
yeah, but I mean if you think about symmetry, so if you move this ester group to the other end of the chain, it will be the same. So that one would actually be the same as this.
Oh yeah.
So they are the same. So it gives
Okay,
you 6.
6. Bang. Okay.
All right.
Do we stop here?
Yeah.